Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about complex numbers. Now the question I've chosen to go through is 2016 Paper 1 Question 1 Part A. In this question we're told that minus 4 plus 3i is a root of the quadratic az squared plus bz plus c. I'm told that a, b and c are elements of OR, and it asks me to write the other root. Okay? Now there's a good bit of theory here. This is a very straightforward question, but I want to really clarify the theory. Az squared plus bz plus c is clearly a quadratic equation. We know that quadratic equations have two roots. I know that one of the roots is minus 4 plus 3i, and I need to find the other root. Sorry, I need to write down the other root. Find, whether the question says find the root or write down the root, implies different things. Find the root means you have to calculate it. You'll have to actually do a sum. If it says write down or it says write the other root, that means that you should be able to just look at your question and write down the answer. So if a question says write down, that implies you should be able to look at it and say what the answer is. The key to this question is that a, b and c are elements of OR. So the number in front of z squared, the number in front of z, and the constant at the end are all real numbers. If you have a quadratic equation where a, b, and c are real, that means that the roots are conjugates of each other. Okay, so that means if one of my roots is minus 4 plus 3i, that means the answer to my question, the other root, is minus 4 minus 3i. So my other root, let's call it z2, is minus 4 minus 3i. But that only applies if a, b, and c are real. Okay, so in this video I want to go directly onto part C, because part A and part C, the theory here is intertwined. Okay, so in part C of this question, you'll notice the wording on it, it looks like it's almost identical to part A. However, it's a completely different kind of question. In this case, I'm given a quadratic again of a z squared, a z, and a number. Okay, so I have a quadratic. Clearly I know that all quadratics have two roots. And I'm told that one of the roots is 1 plus I. I'm asked to find the other root in the form of m plus ni. Now first of all, notice that this time it says find the other root, as opposed to write the other root. So this time I do have to do calculations. The number in front of z squared in this case is a. The number in front of z is minus 2 plus I, and the constant at the end is 3 minus I. So in this case, my a, b, and c aren't real. If a, b, and c aren't real, then that means that the roots are not conjugates of each other. So in part A, b, and c were real, which meant if I knew one of the roots, the other root was just the conjugate. However, that does not apply in this case, because in this case, 2 of my 3 aren't real, which means that in this case, the roots aren't conjugates of each other. So that's just the theory that's really important. Now, the thing with this question is there's any amount of ways of doing it. There's at least 10 different ways of doing this question. So I'm going to focus in on one way. I think for most of you, probably the way that would jump into your heads, first of all, would be to use the minus b formula. That's not the way I'm going to do it, but I think it's worth your while trying to do it out by using the minus b formula. So you could take your a, b, and c, just use your minus b formula, get your two answers. One of them will be 1 plus I, and the other one will be m plus ni. However, I want to use this opportunity to revise a bit of algebra. There's a formula that's in the algebra books, and even indeed it's in our notes in the algebra notes. But for me, it's more of a complex numbers formula. Every quadratic equation can be written in the form of z squared minus z times the sum of the roots plus the product of the roots. Okay, so that turns up in all the textbooks under the algebra, and it turns up in our notes under the algebra. However, it's really more applicable to a question like this. What this means is that if I have a quadratic equation, minus times the number in front of z is the sum of the roots, and the constant at the very end is the product of the roots. Okay, so let's just think about that. So there's two different ways we could use this. I want to hone in on the product of the roots. Okay, I know that one of my roots is 1 plus I. And I know that my other root, for the moment, I'm going to call it m plus ni. So I know that if I multiply this root by this root, I'm going to get 3 minus I. If I multiply 1 plus I by m plus ni, I'm going to get 3 minus I. So let's just multiply out our left-hand side. 1 by m is just m. 1 by n is ni. So 1 by ni is ni. I multiplied by m is mi. I multiplied by ni squared is ni squared. I hope you can distinguish between when I say m and n. Make sure you can read what I'm saying, because I know it sounds the same. And that's equal to 3 minus I. Okay? Now you might be saying that you've one equation and two unknowns, but that's not exactly true. In this case, you should recognize, yeah, that I have one equation and two unknowns, but I can split this into two different equations. I can let the reals on the left equal to the reals on the right, and the imaginary numbers on the left equal to the imaginary numbers on the right. So the real numbers on the left, well, my m is real and ni squared is real. So if I just take the real ones on the left, I get m, and remember I squared is minus 1. So this just becomes minus n. So the reals on the left are m minus n. I know that the reals on the left are equal to the reals on the right, so I know that m minus n is equal to 3. Now let's just take the imaginary numbers. The imaginary numbers on the left are n times I plus m times I is equal to minus I. So now I've got two equations, two unknowns, so clearly this is a simultaneous equation. And I'm going to be able to solve it to find m plus ni. So in this case, let's rewrite this one. So I have ni plus mi equals minus I. So let's just, since there's an I in each term, I can just cancel out all my i's, and this actually becomes m plus n is equal to minus 1. So I'm just rewriting that line, m plus n is equal to minus 1. And now I've just got a very basic simultaneous equation. If I add the one line to the other line, m plus m is 2m, I have plus n minus n, which is 0, and 3 minus 1 is 2. So I know that 2m is equal to 2. So clearly to get m on its own, I'm going to divide both sides by 2. My first value is that m is equal to 1. So I know m is 1. Once I've worked out that m is 1, it's relatively straightforward to get my n. So let's take our top equation here and let's just continue. I originally said that m minus n is equal to 3, but now I know that m is equal to 1. So I can say that 1 minus n is equal to 3. So in this case, let's bring my 1 to the other side. I get minus n is equal to 3 minus 1. So minus n is equal to 2. So if minus n equals 2, I want to multiply across by minus 1. And I can say that n is equal to minus 2. So now I know that my m is equal to 1 and my n is minus 2. I originally said that my complex number was m plus ni. So now I can rewrite my other root of this equation is m, which is 1, minus 2 times I. So the root of this equation is 1 minus 2i. Notice that this root is not a conjugate of 1 plus I. So again, I hope that makes sense. I wanted to use that as an opportunity to revise over this formula. After you've watched this video, it's worth your while. I'd suggest try this by two different methods. I want you to now try it by using the sum of, so I know that minus 2 plus I is minus the sum of the roots. So minus, if you add these two roots together, they should be equal to minus 2 plus I. So see if you can do that and use it to work out that m is 1 and that n is minus 2. It'll work out very similar to the way I did this one. Then also it's worth your while trying to do it by the minus b formula. So subbing in your a is 1, your b is minus 2 plus I, and your c is 3 minus I, and then try and solve it to work out your two roots will be 1 plus I and 1 minus 2i. Okay, so again, I hope all of this video made sense. If you're unclear on any of that, then just send me an email or let me know in class and I'll try and explain it differently.